Hello everybody, I hope you are doing well. Today in this video I'm gonna give a quick but complete tutorial and introduction about SAP 2000. In this video you will learn how to use different tasks here and how to import a project or make a new project, and in general you will learn how to start using SAP 2000. And I hope this is going to be very useful for you, so follow up and please share this video with your friends. And if you're seeking for a new video, if you have a special problem that you wanted to be solved, you can simply write it in comments and I will make a video about your problem and solve it as fast as possible. Okay, let's start. When you have launched your SAP 2000, you simply need to click on File and define a new model. So when you want to when you click on this tab, you will see there are different templates. One of them is blank, in which there is nothing. You have an empty box that you can put anything inside. Then there are grid only. So here we have some grid lines which will help you to build your model. Especially we will use this when we have 2D frame, or when we have all the geometrics of our project. As you can see, there is a template for beam, 2D trusses, 3D trusses, 2D frames, 3D frames, and all of these that you can see. So you have to choose your project based on necessities that you have to follow. So here I'm gonna go with grid only, and you can see that you can have your default units here, which is Newton millimeters right now. You can always change it in here, so you don't need to worry about this. I'm gonna use grid only. Okay, here as you can see we have a it is going to be Cartesian or cylindrical. Today I'm gonna show you how to use this Cartesian. So it's asking how many grid lines we need in each 3 different directions. So you can change it here, and you can give it a default initial spacing for grids. So I'm not gonna change them, but if you want to change them you can always do that. Or let me change it now so you can see. I'm gonna need 3 grid lines in X direction, 4 in Y direction, and 5 in Z direction. I don't really care, and you can always change them. So I'm gonna ask them to give me a bay of 4000 millimeters and let the others to be as it is. And also you can give the software the first line grid line location. So I'm gonna ask it to start from the 0, 0, 0, which is our first location that we're gonna generate our model from. I will click on OK. So here as you can see you have a 3D view and you have a 2D view. So when you are in a 2D view and it is an XY plane, look at here. So if I turn it around, you will see that this direction is X, this direction is Y, and this direction is Z. So when I have an XY direction, XY plane, this is the one. And you can always see the selected plane that we are in. So here we have the XY plane, which has a Z of 12,000 millimeters, and you can see that it is highlighted here in blue. If I change it, you see I click on this tab, and if I change it, it will go and store it down, and you see the Z is 9,000. And if you look at here, you can see the highlighted blue one, and it's as well you can change it. So imagine that you want to see, for example, XZ plane. What should you do is that you will click on the view, set 2D view. So in 2 directions you can always tell the software which plane you want to have a look at. So if you click on XZ, you will see that this line is selected, and if I change it, you see the Y is changed, and in 3D model you can see that if I change it, it will happen again. Okay, so now we have our grid lines. So I'm gonna come to the first plane here, XZ plane, and for example I want to draw a 2D frame. Simply you can use these tools. This is for drawing a frame or cable. So if I want to use this one, I will simply click on that. I will tell them that it's a straight frame. I will not worry about the section because I will define sections in future and assign them later. But it's important how you want the moment to be released. So you can use it as a continuous, or you can use it as a pinned one. I will go with continuous right now. So after you have chosen this tool, you simply need to left click here, come here and click, and another one. You see it doesn't release until you tell it to release. So I will just draw it, and it really, right now it doesn't matter the direction, you only simply need to draw it. In future I will go into details and tell you how the direction of drawing can be effective. So now if you want to release it, you simply need to right click, so it's released, and I will continue doing that from the other sides. Okay, this is one of the ways to draw a frame. But when you have your grid lines, it's simpler if you choose this quick draw frame tool. So you can simply click on it, and then what you need after choosing these as well, you only need to click on the grid, and you see it will draw it as fast as possible. Okay, so now I have a frame, 1 2 3 4 stories and 2 bays. So you have to show what are your restraints here. So you can choose the points and joints, and when you click on them, it's chosen immediately. Then you can come to assign. Okay, if you click on assign and go to joints, there are a task of restraints. You will click on that, and you can see that you can release it in a direction, or you can fix it in a direction. So what are these? Translation 1 is a translation in X direction, and rotation 1 is rotation around X direction. So you can choose these manually, or you can also choose one of these fast restraints options. So I will go with the fully fixed one, and if I click, you can see that it is fixed. So this was drawing a frame and how it works. Now imagine that you want to draw a wall or shell element, or for example a floor element. For drawing them, you will need to use one of these 3 options. This is for drawing a poly area. For example, if you want to draw a triangle, you will need to use this one. If you want to draw a rectangular one, you can use this one. So let me first try this one. I will click on that. It's asking you to select the section. You don't need to worry about that because we're going to do that later. And then I will click on one point or joint, and if you simply drag the mouse and click on the other one, now here you have a section. You have a wall section. Okay, now let's try this poly area drawing section. So I have chosen this. If I simply click on each joints, now you don't have the section yet. So what you should do is that you have to come to the first joint that you started drawing and double click on that. Now you have, as you can see here, you have a triangle section. So just in order to make it more obvious, you can come here and click on this display option, click on it, and for areas here you can tell it to show you the sections. And if you come to general options and tell it to extrude, or maybe let it say standard, and click on fill objects, you will see them. Okay, so now we know how to draw a frame, and we know how to draw a shell area, or a wall area, or a floor area. Okay, so in the view section, you can choose to have 3D view, 2D view. That's what we did. All of the other options that you can see here are here available, so you don't need to click on view very much. What is this? This is for zooming. If you click on it and you drag a triangle, it will zoom on the place that you dragged. If you click on this one, you will restore the full view. What is this one? It says restore previous zoom. So you had previously zoomed on a special place, you want to check it again, you simply click on it. And because my last zoom was this one, the full view, it is showing me now that if I click on this and if I zoom back, it will go back to my previous zoom. And you can always simply zoom in or zoom out. And this is for pan, so you can pan simply. For pan, you can also use your middle bottom of your mouse. So if I click on the middle bottom of my mouse, I can simply do different type of stuffs. And also, if you want to see, for example, now you want to see YZ plane, you simply need to click on this. And as you can see, now we are having the YZ plan, which is this one, because we have the X of 8000, so it's this one, this plane. As you can see, it is highlighted in blue. So I'm gonna change back to XZ, so I have it. And yeah, that's it. So now after drawing your first structure, it's time to go to define. This is a place that our main modeling starts. We will start with defining our materials. It has two template materials for concrete and also for steel structure. Let's see what happens if we click on add new material. So it's asked which region you are going to use your modeling. So I will choose United States, and I want to assign a steel material, and I will tell them to use, for example, ASTM A500, and you can also choose the grades. Okay, if I click on OK, it will be added here. You can always click on the modify button, and you can change all of the parameters. So I will name it to be steel, and you can always change the weight per unit volume, and remember that the units are here. All of these are in Newton millimeters. You can always change modulus of elasticity. For example, now it is 199,000. I will change it to 200,000. Okay, and you can change the Poisson ratio, you can change the coefficient of thermal expansion, and all of them. Okay, so I will click on OK, and now I have a steel material. I'm gonna also add a concrete material, so I'm gonna come here and click on concrete, and the standard, it says customary, so I'm gonna change it to user. Okay, and here you can see the material grade, and you can again change all of the parameters. So here I have the concrete, and this color is the color when you tell the software to show you the sections by the material, it will use this color, so you can know if something is in red, that's a concrete. Okay, Then you will need to define a section properties. So I will come here. As you can see, we have frame sections and we also have area sections. All of the other ones are also very useful, but we don't need them now. So today I'm just gonna tell you how to define a frame section and how to define an area section. Let's start with the frame section. So you can always import some properties from the libraries that are available from the software, or you can add new property. Let's see what happens if we choose either of them. So here, now I'm going to define a steel structure and I want to use some white flanges. If you click on it, you will have access to different standards. So let's see, for example, let's go with ASC15, for example. If I click on it and click open, you will see that there are different sections that you can import. You have to have a vision about the sections that you're gonna need in your project, so you don't need to add all of them. For example, I will use a W8x10, 8x31, and maybe some of these. So you can simply click on the control button of your keyboard and drag the mouse. Click on OK, and you can also see what you've chosen. OK, and now you have all of them. Okay, you will click on OK. Then let's define an area section. So it will ask you if it's a shell, it's a plane, or it's a solid. There are very delicate differences between these three, and especially between these two, so I'm gonna let it to be explained in another episode of SAP Masters video. But let's start with a shell. Most of the walls can be defined as shell areas, so I will add a new section. Again, there are different types. Very important to know which kind you want to use, but normally for the wall section, I will add the name as wall. You can use the shell fin or stick, both of them you can use. Let's use fin today, and I'm gonna teach you in future episodes how they are different. So it will ask you about the thickness. You can tell them, okay, for example, I want it to be 30 centimeters, so I'm gonna choose 300 millimeters. Don't forget that your units are still millimeters, and then bending again 300. So what was the material name? Our material name that we defined was concrete. So I'm gonna choose it and click on OK, and click on OK again. I'm not sure if we chose the correct material here, so I'm gonna click on one of them and click on modify, and as you can see, the material that we've chosen was wrong, so you have to change it to steel as you have defined. So if you at first choose it, you don't need to change it again, but here now, because we have chosen the wrong one, we have to modify them one by one, but I'm gonna pass on that today. Okay, now we have our sections. Then it's time to define a mass source. So it tells you how the computer, how the software will calculate the mass. There are two options. First, you can tell the computer to get the mass only from the element masses, or also get the mass source from the loads. So if you click on modify, you can see that now it's only from element self mass and additional mass. But most of the times you want to have a dead load as a mass, and most of the times it's a lumped mass being represented by a dead load. So you will click on specified load pattern and tell them, okay, I want the mass to be calculated from my dead load. So, and the multiplier, for example, be 1. So you will click on add. So you have the mass source of your dead load. In most of the standards, you will need to define a live load as well, but we haven't defined the load, so I will click on OK and click on OK. So let's go and define some load patterns. Here are the place that you are defining what kind of loads you have. You already have a dead load and the dead load always have the self weight multiplier of 1. Okay, so I will add a live load as well. Simply type live, and on the type you have to click on the live. It's normally 0, and you have to click on add new load pattern. So now we have 2 loads. So click on OK. Go back to mass source and modify. So most of the standards tell you to add a 20% of your live load as well for the mass. So it's 1 dead plus 20% of live load. Click on OK, yes, and OK, done. What we need to do is now we will need to define a load case. So as you can see, the software now asks you under which load cases you want your model to be analyzed. So here by default it will analyze the dead load, modal, and live load. As you can see, there are different load case types. So if you modify them, you will have a very large amount of possibilities here. Normally, when you want to do a modeling, a linear static dead load will be enough. But in most of the cases, when you are doing a research, you will need to use different load cases. So if I click on this, you can see that we have static, multi-step static, modal, response spectrum, time history, moving load, buckling, steady state, power spectral density, and hyperstatic. So in another video, I'm gonna teach you what are the differences between these, but let's start with this one. For example, I want a dead load, but I wanted the analysis type to be nonlinear. So I can simply click on nonlinear, and when I click on nonlinear, you will have some parameters added to your analysis type. So here asks you, what is the load application? Do you want the full load to be happen? If you click on modify, you will see that you have 2 options. What is a displacement control? So in most of the tests which are done on the laboratories, you are not applying, or maybe you are not monitoring your test by the load protocol. You are modifying or monitoring it by your displacement protocol, because you want to tell it, okay, when you reach to 40 millimeters, stop the test. Okay, so here you can tell them, okay, I want it to be a displacement control and I don't care in which load it will happen, but when it's reached to 40 millimeters, stop the analysis. And where I want it to happen, for example, here it says at joint 5, you have to check which joint you want. So we have to do that here, and if we click on this after I close this window, you will see the joint ID, but I'm gonna click on OK and use it. And also for result save, it says, do you want the final state only? Normally when you're doing research, you will need the behavior of your structure in multiple states, so you can tell them in how many steps you want it, and it will show you the results in 100 different steps. Okay, so right now I'm gonna go with linear because it's faster, and I will teach you how you can use any of those load types in other episodes, because this is only a general introduction of SAP2000. Okay, let me show you how you can see the joint ID. If you click on it and right click, you can see the label is 5. There is also another easier way to see your joint. So if you click on set display option, you see here is the joints. If you tell them to show me by labels and apply it on both windows, you can see the label of each different joint. Okay, and now it's time to assign some loads. Imagine that you have a distributed load on this frame. What you need to do is that you simply drag or you simply click on the frame. But if you want to apply a distributed load on a large number of frames, you can drag and select all of the frames. Now the frames are selected, and also some sections are selected, some area sections are selected, but you don't care, because when you want to assign a load, you can come to assign and come to assign frame loads, because you are only assigning a frame load. It won't happen to the area sections. Okay, so I want a distributed load here. What is a load pattern? It's a dead load, and I want it to be a uniform load of, for example, 50 Newton per millimeter. And if I click on OK, you will see that the distributed load is applied on the model. Then I want to again apply and assign a live load on my structure and my frame. So I will come to assign frame loads, gravity, but this time, or let's make it a distributed load. Let's make it a live load here. And I'm gonna tell a uniform load of 20 Newton per millimeter. And it asks you if you want to replace it or add it to existing loads. Be careful, because here when it says replace, it doesn't mean replace with the previous dead loads. It says replace with previous live loads, which is none here. So okay, and you will have a 20 Newton per millimeter for each frames. So if you want to check and see if you have assigned the right amount of loads for each frame, what you should do is to simply click on one of the frames and right click on it. So you can see all of the assignments here, right? Section property, we haven't assigned the section property, so it has used the default one, but we are checking about the loads. As you can see, there is a 50 Newton per millimeter at 0 and at 4000, so it's a dead one. And we have also applied a live load, so it's all correct. Okay, now it's time to assign some frames. So I will click on, for example, these ones. Okay, let me do like this. I want the columns, so I will only click on them, come to assign frame and frame section. So I want the columns, for example, to be a W10 by 49, so I will click on it, apply, and okay, now I have these sections for columns. But as you can see, because I haven't chosen these frames, so they are still the default one. Let me choose these four excuse me, and assign them. Again, you come to assign to the frame section, and let me choose with this one. And for these four, I will come to assign and click on frame section, and for example, I want it to be like this. So now I have all of my frames assigned. Let's see how we can assign an area section. You can simply click on them, come to assign, and click on area in the area sections. We have defined a wall. Okay, so we have the two walls here, and now everything looks fine. Now we are ready to start our analyze, right? So if you click on analyze and set analysis option, you can see there are different options. Here now, because we only have a 2D frame, I will use a plane frame, and pay attention to this one. If I click on it, you will have some degrees of freedom unchecked. Okay, and if I click on analyze again and come here, you can tell them which one you want to be run and which one you don't want. For example, now I want 3 of them, all of them to be run. So I will simply click on run now, and it asks you where should I save it. So I will come to YouTube and I will tell them introduction. I will name it introduction. I missed an R. Okay, save it, and now it will start running. if anything wrong doesn't happen. Okay, as you can see here, now you can see the deform shaped under the dead load. How you can check it, and you can also use the start animation to see how it deforms. Stop it. Okay, what is this? This shows your deform shaped under the dead load. For example, you want a scaling to make it more obvious. Now it's 1. Let's make it 10 and click on OK. Start animation. And if you change the scaling, make it for example 500, you will see it's more obvious. But normally the best choice is to use the automatic. It will show you a good amount. Okay, you can also check the deform shape on different load cases. So now I want to show me the modal case. And you can see here also in modal case, you can check the period, fundamental period of structure, and also fundamental frequency of structure. And you can see the deformation for each mode. If you click on this arrow, you can check it for the second mode, also third mode. And I don't think we have defined more. Oh yeah, we have defined more, so you can always check all of them. So this is one way. And also you can see the forces here. So if you click on this one and click joints and tell them to show you the dead loads, you will see the loads that has happened in your joints. You can also tell them to show the loads in the frames. So for example, I want to see the axial force for frames. If I click on it, you can see that it is shown in this kind, but you can also change them to, instead of filling a diagram, you can tell them to show the values and apply, and it will be very obvious how many how much loads and forces have been applied and how much forces have been induced. And there's also another way. So if you come to display and go to show tables, you will find every information about your model here. So these ones are the definitions, are the inputs, so you can check them all the time, so make sure that you haven't made a mistake. Or these are the outputs. For example, if I click on joint output and I want to see the displacement, I will click on it and come here and select your load cases. For example, I only want the dead load. Okay, and here if you have, for example, a cyclic loading, you can tell it to show you it step by step. Right now we will only see the final results because our loading is not a cyclic one. If I click on OK, you will have all the information about joint displacement, each joint in every direction. You have the values. Okay guys, this is it. It was only an introductory and general information about SAP 2000. I hope it was useful for you. I again ask you to subscribe to our channel and stay tuned, because we are gonna teach you literally everything that you need to know about SAP 2000 to become a good engineer and pass all your exams in university. If you are a civil engineering student, if you are a structural engineering student, you definitely need to know how to use SAP 2000. And after finding a job, if you don't know how to use SAP 2000, it will be a very big problem for you. So stay tuned and tell us what you want us to teach you. Thank you so much. Have a good time and bye bye.